Hey guys, welcome to Final Exam Review. This video is going to cover part one of the final exam review. You can see that certain pages are marked with different parts. That's kind of how I'm trying to divide up the videos here. So part one should cover problems 1, 2, and 3. So I'll just go ahead and kind of get started on this. One quick note though, when I do these problems for the final exam review, I'm going to be focusing on the technology aspect of doing these problems. If there is something that you want to calculate by hand or do by hand, you can see the by hand calculations on the answer key that I provided on MyOpenMath. My goal in this video is to show you the things I can't show you on the answer key, such as how to do like calculator inputs and things like that. I would also highly recommend for the final exam that you, if you can, do the problem with your calculator. Use the calculator to run your hypothesis tests and your confidence intervals and things like that. Just because I don't want you guys to get pressed for time. So the test is designed for you to use the technology. Okay. If I want something calculated by hand, it'll be specified on MyOpenMath. All right, so let's go ahead and dive in here. Just to kind of get started, the first thing that I would do is go ahead and enter this data for the mass of the silver dollars into list one. I'm going to use this same data set for every problem in part one. So problems 1, 2, and 3 will all use this data. So it's worth your time to go ahead and enter it into your calculator. It'll save you a little bit of time later on. All right, now if you forgot how to do that, to enter data into your calculator, you're going to go to Stat, and you're going to choose the Edit option, which is number 1, and then you are going to just type in your silver dollar masses here into list 1. All right, you just type them in there, and it'll automatically save, so you can quit out and go back to the home screen. All right, so let's just take a look at this first problem. It says find the mean and the standard deviation, and we are finding the mean and the standard deviation of a sample. So it specifically says use the correct symbol. So if we're looking at a sample, the sample mean symbol is an X bar. Okay, so when I write my answer, I want to make sure that I use X bar, and the correct symbol for a sample standard deviation is just a lowercase s. On the calculator, they'll put a little X on it as well. All right. Now, if we were doing this for a population, you would be using the Greek letter mu and for the mean, and you would be using sigma, which is it's a lowercase sigma. That's what they use for the population standard deviation. There's going to be a couple questions where they're going to ask you about these symbols, so make sure you know the correct symbols for different things. Those should be in your chapter 1 notes. Okay. So let's go ahead and find these two things real quick using our calculator. Remember, we have our data entered into list 1, and the quickest way to find a mean and a standard deviation is to use the 1var stats option on our calculator. So I'm going to hit stat, I'm going to go over to the calc menu, and the very first thing that pops up here, the very first option is 1var stats. This gives us a whole bunch of information about our data. So I'm just going to enter that in and hit enter, and you'll see all of the numbers that kind of pop up here. Our population mean is up here at the top. So that, or I'm sorry, our sample mean is up here at the top. So we're going to say 26.743. And then our standard deviation from the sample was 0.113. All right. Just another thing that popped into my mind about MyOpenMath, make sure you read the directions about rounding. Different problems will have you round to different decimal places, so make sure you read those instructions very carefully. If you're getting a problem wrong, check your rounding, see if that's what the issue is. So I don't want you to get caught off guard by that. All right. Next thing they want is the 5-number summary. Remember, the 5-number summary includes the minimum, quartile 1, the median, or quartile 2. Sometimes they call it quartile 2. And then quartile 3, and our max. This is our 5-number summary. And you can get that all from your 1var stats that we've already run. You'll see they put the 5-number summary down here at the bottom, so you'll need to scroll down. And so you start with the min at 26.53. And then just pretty much in order the calculator gives it to you there. So 26.67. The median was 26.745. The third quartile was 26.8, and the max was 26.96. Okay. And don't forget what these are. The median is like the 50th percentile. It splits our data set in half physically so that 50% of the data is on the left and 50% of the data is on the right. Quartile does the same thing, except it separates the bottom 25% from the top 75%. All right, and it is to get these numbers, you do have to list these in ascending order. Now, the calculator does that for you automatically, but again, if you were doing it by hand, you would have to take your data and arrange it in ascending order and then chop it up into fourths, essentially, to get these numbers. All right, okay. So letter C says construct a well-labeled box and whisker plot. Now, I didn't draw this live for you because using this digital pen is just it's very annoying to try and draw this with my pen. But I did it, and I wanted to do it off camera because it would be very boring to just watch me draw a box plot, especially with this pen. All right, so I'm just going to give you some pointers here. A box plot, right? This is remember there's two different kinds. There's the modified box and whisker plot, and then there's just a regular box and whisker plot. All right, so what I've drawn here is the regular box and whisker plot, so the whiskers just extend all the way out to the min and the max. All right, so when we draw this, the first thing you want to do is just draw a horizontal axis. Make sure you put some tick marks on it. Try to evenly space them out. You could use your ruler to do that, or something that'll allow you to notch this evenly. You don't want to have like a big gap like I do here in between these two and then a little one like this one, because it distorts your box plot. All right, so you want to make sure those are consistently spaced, and then you want to make sure you put a scale down here. All right, so it should be going up by the same value every time. Make sure you label. All right, this is a big one. Remember, this is that nitpicky stuff that we lost points on the quizzes in the beginning of the year. Make sure you label your axis with what it is in the units. Okay. Now, when you make your box plot, the left whisker, that's going to be your minimum. The right whisker is your maximum, which you have labeled here when you did your 5-number summary. The first quartile is the left edge of the box. The second quartile, or the median, is the line that goes inside of the box. And then the right edge of the box is our third quartile. All right, that's really all there is to making a box plot. All right. So I might give you a question where I have you draw one of those by hand or create that on your calculator or something like that. You can take a screenshot or take a picture of it with your phone and just submit it through MyOpenMath. You just click Attach File and upload the file. All right, so let's take a look at the next one. This is the next graph that we'll do. This is the histogram. This is probably the most important statistical graph there is. As you've seen, pretty much everything relies on normal distributions and the shape of your distribution, and that's what the histogram shows us, is what is the shape of our distribution. Okay, so to create our histogram, we have to choose a certain number of classes. All right, and remember the minimum is 5 classes. Typically, any stats textbook or any stats standard is going to go with a minimum of 5 classes. From there, you can calculate your class width. All right, you subtract your max and your min, and you divide by the number of classes that you choose. So I chose 5 classes for this problem to create my histogram over here. There's my max, there's my min. I subtracted and then divided by 5, and I got a class width of 0.08, right? 0.086. But that's not something that I can easily count by. All right, I want to count by something nice, something that I can, like 2s or 4s or something like that. This is decimals, so we have to be a little bit flexible here. So I'm going to go up by 0.1s. I can count up by 0.1s pretty easy. All right. Once I know what my class width is, you start at a value that is less than your minimum. So I started at 26.5, which is slightly less than the 26.53, and then just went up by 0.1s from there. And I drew only a small part of my frequency table because I don't actually need the frequency table. I just need to envision what it looks like to help me set up my histogram. Okay, so remember these numbers that you see here, 26.5 and the 26.59, those are the lower class and the upper class limits. When we create a histogram, the x-axis has to have class boundaries. And the boundaries are the numbers that happen in between the upper class limit and the lower class limit. Okay, so the number in between 26.59 and 26.6 is 26.595. That's where that came from. Once I have that number to go left or right on the x-axis, I just go up by 0.1. So 26.595 goes up to 26.695, 26.795, 26.895, so forth and so on. Okay. And then I keep going until I have a spot for all 5 of my classes. And then you just have to go into your data and figure out how many pieces of data are in between these two values. How many pieces are in between these two values? And then draw your bar up to that. That's called a frequency. All right. So when I went through my data, I only found one piece of data that was in between 26.495 and 26.595. So I drew my bar up to 1. And then I did the same thing here. And I found 4 pieces of data that fit in this class. So I drew my bar up to 4. Okay. And then I look at my data, right? Because the whole point of constructing a histogram is this, right? To describe the shape. And this thing is what I'm going to say is fairly or approximately normal. There's a couple of ways to say this. Approximately normal. It's not perfectly normal. Got a little bit higher of a left bar over here than on the right side. You can say fairly symmetrical. And bell-shaped is another one. So these are all the words that we learned to describe this particular shape. Don't forget, make sure you review what like skew right and skew left look like. Also make sure you review what a uniform distribution looks like. Those are all in your chapter 1 and your chapter 2 notes that we did at the beginning of the semester. Okay. There's also the textbook online that'll show you examples of that as well. All right, so let's go to the next problem here. This one is estimating the mean mass of the silver dollars. So I'm gonna start you off just by saying this is a t interval. Okay, so this is a t interval. All right, and you need to be able to identify like right away, like after you read a problem, you should know like, oh, this is a t interval or a z interval or it's a t test or a z test or you know something like. You have to be able to pick apart the problem and decide what it is that you are doing. Now, the reason that I knew this was a t interval is because I saw this word estimate. We're estimating something. And confidence intervals, right? Intervals estimate stuff. All right. We're also estimating a mean, right? That's a key word there. We're estimating a mean. And to estimate a mean, we were going to use either a z or a t interval. And the reason that I knew that it was a t interval is because this problem told me nothing about this, right? The population standard deviation is unknown. Okay, so what I just did there is a large chunk of the problem. It's most of the problem. It's just identifying what test or what interval you are doing in your calculator. All right. Now, like I said, your by hand calculations for these items down here, it's all in the key. You can read those and see how I calculated each of those things. I want to show you how to do this on the calculator, so when you get to the final exam, you know what you're doing on the calculator. Okay, so like I said, we're going to be doing a t interval. Get my calculator turn on here, and this time we're going to go to stat. We're going to go over to tests, and we're going to go down until we see t interval, which is option number 8. And so there's option 8 right there for t interval. And we're going to use the data feature. Since we put the raw data into the calculator, I can just tell it, hey, the data is in list 1, and the calculator will take care of everything else for you. If it has the raw data, it's actually a lot easier. And we're running a 90% confidence interval. So I'm going to go ahead and hit calculate. And there it is. So we got our confidence interval. I'm going to go 26.694. Okay. And the other one was 26.793. Okay. And so there's my interval. All right. And I can also write this in an inequality format as well. So I'm going to take the parameter that I'm trying to estimate, which is the mean, and I'm going to put it in between two inequalities. So my 26.694 over here and my 26.793 over here. So it's a fancy mathematical way of saying that m is in between, or not m, but mu, or mean, is in between these two values. The other way to do this is to use your point estimate with a plus or minus the margin of error. Okay, so our point estimate was actually the mean of our sample that we took earlier. So we would say 26.743 plus or minus whatever the margin of error is. The quickest way to get the margin of error is to take your point estimate and subtract from it this left bound. So I can take 26.743 and subtract the 26.694, and when I subtract those two things, I should get a margin of error of 0.0495. Okay? So I would say 26.743 plus or minus 0.0495. All right. So I was able to find the margin of error using this, and my point estimate was the mean that we had before. So that's how you would do most of the problem, just by using your calculator. Now, the last part that it says here, that's my 90% confidence interval in all three of the formats. But the last thing that we have to do is we have to interpret the meaning. Okay. So for your interpretation, you want to use wording that is specific to the problem and do not use any statistical symbols in your interpretation. All right. So you don't want to just say we're 90% confident the mean is in between these two values. We want to say we're 90% confident that the mean mass, or the true mean mass of all silver dollars, is in between these two values. Okay, so adding the context, what it is we're estimating in the context of the problem, is important. So we are 90% confident the mean mass of all silver dollars, and this is important, all silver dollars, is between 26.694 and 26.793. Now, I know a lot of people don't say the all part. If you just said the mean mass of silver dollars in general, I typically accept that. Just make sure you don't put any wording in there that says the mean mass of one silver dollar, or the mean, or the sample mean of silver dollars. We're estimating the population mean. Okay, so we're 90% confident the population mean is in between these two values. Population is a reference to all silver dollars. All right. Let's go to the next problem. Let's take a look at number 2, and let's see what we've got here. So read the problem carefully, decide what you are doing. You might want to pause the video and just decide, what are you doing, a t-test, a z-test? Are we doing a confidence interval? Are we calculating probability? What are we doing? So pause the video, read the problem, take a guess, and let's see if we can get the right one. Okay, so this one is a t-test. So this is a t-test. Reason being is because someone is making a claim. All right, they're making a claim about silver dollars. Right, so is there evidence at a 5% level of significance that the mean mass of silver dollars is different than 27.3? So this is a t-test because we are making a claim, right, about the mean. So if we know that it's a claim, it's a hypothesis test. If we know that it's a claim about the mean, I know it's either a t-test or a z-test. And the way that I know that it's a z-test is, again, we don't know the population standard deviation. We don't know this thing. Okay, so that's how I know I'm doing a t-test. All we need to do for this one is set up our null and our alternate hypothesis. So the claim, right, if you read the problem carefully, the claim is that the mean mass of silver dollars is different than 27.3. So they're saying the mean is not 27.3. So when I set up my null and alternate hypothesis here, okay, the null hypothesis always has the equality in it. So I'm going to say the mean equals 27.3. This is our population assumption, and the contradiction is our claim. So we're going to say the mean is not 27.3. So that's the setup of my null and alternate hypothesis. I need to see that. It's also not a bad thing to say that this is a two-tailed test. So, you can mention in there it's a two-tailed test. All right, the next thing that we need to do is go ahead and run this test on our calculator. So we're going to use the t-test function on our calculator. Let me show you how to do that. Stat, we're going to go over to tests, and then the second option here is a t-test, which is option number 2, and it wants all of your information. And remember, we put that data into L1, so we can just use the data option here, And I'm going to go down. It does need to know what your null hypothesis is. So we're going to say it's 27.3. Okay. And we're going to tell it that our data is in list 1. Don't mess with the frequency. And then we're doing a two-tail test. So I need to switch that to not equals to and hit calculate. Okay. So the first thing they give you here, that is your test statistic. That tells you how many standard deviations away from what you expected you are. And then the probability of getting that far away is our p-value, which is the next option here, 3.95 e to the negative 12. Okay, so test that. Our test stat was negative 19.69. So, and remember for this one, our test stat is just going to be a t. So negative 19.69, and then our p-value was 3.95 e to the negative 12. Okay. So remember, when you see that e to the negative 12, what that means is this is 3.95, but with like 12 zeros in front of it. So it's actually a really, really small number. It's the same thing as saying like 0 plus. Right? I had a lot of people on the test confuse that. They actually wrote that a probability was 3.95, and that's impossible for a probability. Probabilities have to be in between 0 and 1. Okay, so you get that e negative 12, it's 0 plus. It's a very, very small probability. All right, last thing we got to do here is compare the p-value to alpha. So we're going to do our comparison here so that we know what to do. Okay, so our p-value is 0 plus. Our significance level here was 0.05. 0 plus is less than 0.05, so this is telling us to reject the null hypothesis. We do not believe this because this was too rare, all right? Which means if I don't believe this, then I must believe this. All right, so what we did is we found enough evidence to support our claim. All right, so I'm going to go ahead and say that this is our conclusion. All right, and we want to make sure that our conclusion is a complete sentence without any statistical symbols. This is where you try and translate all this stuff that you did mathematically to people who have no idea about hypothesis tests, all right? You've got to translate this in plain English to the people that you work for so that they can make a decision. There is sufficient evidence to support the claim that the mean mass of all silver dollars is different than 27.3 grams. All right. Let's look at number 3. It says it is assumed that 85% of all silver dollars will meet the exact specifications for weight and size to be put into circulation. Quality control engineer believes that the proportion, it's an important piece of information, the proportion has decreased. To test his claim, that's important, he takes a simple random sample of 78 silver dollars and finds that 63 of them met specifications. Use a hypothesis to test. That's also important. To test an alternate hypothesis, p-value, and what to do with the p-value and state a conclusion in a complete sentence without any statistical symbols. All right, so obviously the problem literally tells you we're doing a hypothesis test. It's a hypothesis test on a proportion. So this is a one prop z-test. Okay, so one prop z-test. And we're going to go ahead and set up our null and our alternate hypothesis here. So it's always good to kind of say, okay, well, what's the claim? So the quality control engineer believes the proportion has decreased. So his claim is that the proportion is less than 0.85, right? Because it's assumed that it was 85%. So this is our claim right here. The claim is that it's now less than 85%. So I'm going to put our population assumption here. I'm going to say the proportion is 0.85. I'm going to say it's equal to 0.85, but our claim says that it's less than. Okay, so the contradiction to that would be that it's less than 0.85. So this is going to be a left tail test. Okay. So I need to see that null and alternate hypothesis set up correctly. The next thing I need to see is the test stat. And I need to see the test stat, and I need to see the p-value. You see those two things. You can get those from the calculator. All right. Like I said, I'm gonna focus on the technology aspect here. all of the by hand stuff, if you want to see that again, make sure you look at the answer key. I did it all on there for you. All right. So we're going to go stat. We're going to go over to tests. We're going to go down until we see one prop z-test, which is option number 5. That's one prop z-test. And we're going to tell it what was our population assumption. It was 0.85. And this is where it wants to know how many successes you had. We had 63 of those silver dollars meet specifications out of 78, right? Our sample size was 78. I'm going to change this to a left tail test, and then I'm going to click calculate, right? And there it goes. It gives us our test stat, and it gives us our p-value right there. So my test stat, this time being a z, right? That's why I call it a z-test, because it's a z-score. And that was negative 1.046. So a little over 1 standard deviation away from what we expected. We expected 0.85. We were about 1 standard deviation to the left of it. All right. Doesn't seem like it's that rare, right? Which the p-value kind of corresponds with, right? We got a p-value of 0.148 if I go to 3 decimal places. So 0.148, so about a 14.8% chance that could just happen by chance. It's kind of rare, but not rare enough. All right, because remember, we have to compare that p-value to our significance level. All right, so this is where we do the comparison. All right, we take our p-value, which is 0.148, we compare it to our level of significance, which I did not state for this problem, but we'll just run with a 0.05 here. So 0.05, and 0.148 is greater than 0.05, so this is telling us that we need to fail to reject our null hypothesis. It wasn't rare enough for us to stop believing this. All right, so we're going to go ahead and keep rolling with the assumption that 85% of these coins are going to meet specifications. So we're going to go ahead and write our conclusion statement like this. There is not sufficient evidence to support the claim that the proportion of silver dollars that meet specifications has decreased. Right? So if we had rejected the null hypothesis, we would then be supporting the alternate hypothesis, but there just was not enough evidence for us to stop believing this. Therefore, we can't support this, not with the data that we have. All right. Make sure when you write that conclusion in one of those essay style questions that it is written in a complete sentence and that it's written in the context of the problem. All right, guys, that's it for part 1. Hopefully you found that helpful. If you still need more help or need more detail on anything, check out the answer key. I was very detailed on there, but also schedule an appointment with me for some tutoring if you feel like you need it. All right, guys, good luck.